This is worksheet 25.4, and we're looking at number 12 and 13 here. Tina, Louise, Jean, Jimmy, and Zeke all need a ride to a friend's party, but their ride only has 2 seats left in the car. They decide to put their names in a hat to randomly select who gets a ride. How many outcomes are there? List them. So we could list out each pair of people. So Tina could ride with Louise, Tina could ride with Jean, Tina could ride with Jimmy, Tina could ride with Zeke, and so on. If you list them all out, you'll come up with 10 different pairs that could go in the car. But that's not always a very efficient way of calculating the number of combinations that could occur. So if we were to represent this total as a factorial, we could use the total number of people. So we have 5 people, and then factorial. But if we were to just leave it like that, so 5 times 4 times 3 times 2 times 1, we're not going to get 10. We're going to get a number much bigger than 10. Because doing this is assuming that Tina and Louise would be different than Louise and Tina. Different arrangements. But the order doesn't matter on this problem, so Tina, Louise is the exact same thing as Louise and Tina, so we don't want to include those twice. So when we do something like this, it's called a combination instead of a permutation, and we need to divide by both the number of people that did go in the car, so 2 factorial, as well as the number of people who didn't end up going, 3 factorial. If you were to simplify this out, you should get 10. So 5, 4, 3, 2, 1, 2, 1, and 3, 2, 1. These cancel, so you get 20 divided by 2, which gives you 10 total weights. Let's also look at another example of combinations. On number 16, we have 16 people waiting for a bus, but there's only 7 seats available. How many different ways can the 7 riders be selected? So again, we're not arranging these people, we're just choosing 7. So a decision chart wouldn't be appropriate because it doesn't matter what order these people are chosen in. So if I go straight to factorial notation, we have 16 people total. And in the denominator, not only do we need to include the number of people who are getting selected, but also the number that are not. So 7 seats are available. That means 9 seats, or 9 of the people will not get seats. So simplifying this, one shortcut you can use when you're using a larger number here is you know that 9, 8, 7, 6, 5, 4, 3, 2, 1 is going to cancel with the 9 factorial here. So instead of writing it all out, I'm going to end the numerator with the 9 factorial because it's going to end up just canceling with this one. And then we have 7, 6, 5, 4, 3, 2, 1. You could also try reducing some of this if it helps. 7 and 2 go into 14. The 4 and the 3 go into 12. And you can reduce these as well. After reducing and multiplying everything out, you'll get 11,440 different ways.